You've seen surds in Trig. You've simplified them. You've rationalized them. But what is a surd, and why does it matter? This is the long-form companion to our half a dozen surds series. Bite-sized shorts that show surds in action. Now let's zoom out and see the full picture. A surd is an irrational number written as a root, usually a square root. It can't be simplified to a whole number or fraction. Examples include the square root of 2, the square root of 3, and the square root of 5. These go on forever as decimals, never repeating. We leave them in root form to keep answers exact. The word surd comes from Latin surdus, meaning deaf or mute. It was used to translate the Arabic word asam, meaning deaf root, which itself came from the Greek word alagos, meaning speechless or irrational. So a surd is a number that doesn't speak. It can't be expressed as a neat ratio or decimal. An irrational number can't be written as a fraction. Its decimal goes on forever without repeating. Examples include the square root of 2, pi, and e. Surds are a way of writing irrational numbers exactly, without rounding. Why do we use surds? Because they keep calculations accurate. No rounding errors. Engineers, architects, and physicists use them to model real-world problems. Your calculator might say the square root of 3 is 1.732, but the square root of 3 times the square root of 3 equals 3, exactly. Surds also show up in trigonometry, geometry, and algebra. For GCSE Foundation, you don't need to prove irrationality. You just need to work with surds. Key skills include simplifying surds, like the square root of 50 equals 5 square root 2. Adding and subtracting like surds, like 2 square root of 3 plus 3 square root of 3 equals 5 square root of 3. Multiplying and dividing surds. And rationalizing denominators, like 1 over the square root of 2 becomes the square root of 2 over 2. You'll also see surds in trig, like tan 30 degrees and sin 60 degrees. To simplify surds, find square factors. The square root of 72 becomes the square root of 36 times 2, which simplifies to 6 square root of 2. Only like surds can be added or subtracted. Multiply roots. The square root of 2 times the square root of 3 equals the square root of 6. Expanding brackets, the square root of 2 plus 1 times the square root of 2 minus 1 equals 2 minus 1, which is 1. Beyond GCSE, surds show up everywhere. In engineering, for bridge design and diagonals. In physics and for wave equations and resonance. In architecture and for angles and proportions. In finance, for compound interest. And in computer science and for signal processing. They're not just abstract and they're practical. In our series Half a Dozen Surds, we showed key surds in action. From trig triangles to simplification tricks. Want to practice? Download the worksheet linked in the description. It includes GCSE-style questions, worked examples, and a parent guide. Surds are just irrational numbers in disguise. Learn the patterns and they'll start making sense. Subscribe to Dozen Works Maths for more hacks, guides, and confidence-boosting content.